Hello guys, my name is Neha. Welcome back to Intellify. Here we are going to solve NCERT question of chapter number 11, three-dimensional geometry from mathematics, class 12, exercise 11.3, question number 1. The question is, in each of the following cases, determine the direction cosines of the normal to the plane and the distance from the origin. Part A is z equals to 2. Part B is x plus y plus z equals to 1. Part C is 2x plus 3y minus z equals to 5. And part D is 5y plus 8 equals to 0. Here we have part 1 is the equation of the plane is z equals to 2. So we can write it as 0 multiplied by x plus 0 multiplied by y plus z equals to 2. The direction cosines of the normal would be the coefficients of x, y and z. So the direction cosines of normal we have here are 0, 0 and 1. Now to convert direction ratios to direction cosines, we have to divide this from the sum of square root of direction ratios. The value we get is 1. So after dividing our equation number 1 by this, we get the equation 0 multiplied by x plus 0 multiplied by y plus 1 multiplied by z equals to 2. This is the form of the equation Lx plus My plus Nz equals to D, where L and N are direction cosines of normal to the plane and D is the distance of the perpendicular drawn from the origin. Thus, the direction cosines are 0, 0 and 1 and the distance of the plane from origin is 2 units. That's the required answer for part A. For part B, we have equation x plus y plus z equals to 1. Here, the direction ratios are multiplies of x, y and z which are 1, 1 and 1. Now, we will divide it by the sum of square root and we get the value under root 3. On dividing by this value, we can convert direction ratios into direction cosines. So after dividing this equation by root 3, we get x divided by root 3 plus y divided by root 3 plus z divided by root 3 equals to 1 by root 3. Now this equation is the form of Lx plus My plus Nz equals to D, where L and N are direction cosines of normal to the plane and D is the distance of normal from the origin. Therefore, the direction cosines of the normal are 1 by root 3, 1 by root 3 and 1 by root 3 and the distance of normal from the origin is 1 by root 3 units. That's the answer for the second part. For the third part, we have equation 2x plus 3y minus z equals to 5. The direction ratios of normal we have here are the coefficients of x, y and z, which are 2, 3 and minus 4. So what we will do is we will divide it by the sum of square root and we get the value under root 14. Now if we divide this equation by under root 14, we can convert direction ratios into direction cosines. So we will divide it by root 14 and we get the value 2 by root 14 into x plus 3 by root 14 into y minus 1 by root 14 into z equals to 5 by root 14. Now this equation is on the form Lx plus My plus Nz equals to D, where L and N are direction cosines of normal to the plane and D is the distance of normal from the origin. Therefore, the direction cosines of normal to the plane are 2 by root 14, 3 by root 14 and minus 1 by root 14. And the distance of the normal from the origin we have is 5 by root 14 units. This is the answer for the C part. Now for the D part, we have equation 5y equals to minus 8. Here we can write this equation as 0 multiplied by x minus 5y plus 0 multiplied by z equals to 8. Now the direction cosines we have to find out. For this, we have direction ratios as 0, -5 and 0. Now we will convert direction cosines as divided by sum of square root. So we have the value 5. After dividing it, we get the value of equation minus y equals to 8 by 5. This equation is of the form Lx plus My plus Nz equals to D, where Lm and R direction cosines of normal to the plane and D is the distance of normal from the origin. Therefore, the direction cosines of normal to the plane we have is 0, -1 and 0, and the distance of normal from the origin we have 8 by 5 units. That's the answer for the D part. That's our answer. Thank you.